Welcome back everyone. We're going to be solving LeetCode 112, path sum. So we're given the root of a binary tree and an integer called target sum. We need to return true if the tree has a root to leaf path such that adding up all the values along the path is going to be equal to the target sum. And they define a leaf to be a node with no children, so 7, 2, 13, and 1 will be the leaf nodes. And we're going to be solving this problem iteratively. I feel like a ton of people like to solve this type of problem recursively, and then when they're asked to do it iteratively, they have no idea how to do it. So we are going to do it iteratively, and we need to find a path from the root to a leaf. So we're obviously going to be using depth first search here. So in that case, we know we're going to need a stack. So we'll make a stack and we will put the root on. And before we go any further, we're going to check our base case. Our base case is going to be if we don't have a tree or our tree is empty, then that clearly means we can never find the target sum, so we can just return false, right? So we'll say if the root is none, we can just return false. Otherwise, we're going to continue on. Okay, so depth first search uses a stack. We have that. We've got our root on there. And we want to also, we're looking for a target sum. So instead of only putting the root on, right, we're going to use a tuple, and we are going to put the root on along with the total sum so far. So every time we hit a node, we're going to calculate this total sum. And if the total sum ever reaches our target sum, then we're going to return true. So how can we do that? Like I said, we're going to use a tuple where the first value will be the root node. The second value is going to be the sum, and we have to start off with the root dot value. Okay, so now that we have that, we're going to say while the length of our stack is not equal to 0, or while there are values still in our stack, we are going to get the node and the value so far, or the sum. What should we call this variable? Let's just call it summation. So we're going to get the node and the summation, which is going to be equal to stack.pop. Now, if we ever run into a node that has no left or right children, that means we found a leaf node. So we have to, let's check that first. We'll say if node.left is none and node.right is none. What are we going to do? We're going to check to see if the summation is equal to the target sum. If it is, we're going to return true. So we'll say if summation is equal to the target sum, we return true. Otherwise, we're just going to keep going with our with the rest of our loop. Okay, now that we've got that out of the way, we need to add nodes onto our stack along with the summations. So in order to do that, meaning they're not leaf nodes, so we'll say if node dot right is not none, what do we want to do? We want to say stack dot append a tuple, right? We're working with tuples. We will append node.right. And how are we going to calculate the summation? Well, we can just take the summation and then add that to the node.right's value. So we'll say summation plus node.right.val. So in the case of the first iteration, right, our summation will be 5. We know there's a right node. So we're going to take 5 plus 8, and that'll give us, what, 13, right? And that will append that node onto our stack. And then we're going to keep going. All right, so now let's check the left. If left is not none, we will say stack.append a tuple node.left along with the summation thus far plus node.left.val this time. And then if we ever exit this loop, that means this block never returned true, so we can just do a latent return false. And this should give us our answer. So let's run this. And we do pass all 3 test cases, so we'll submit. Perfect, it does pass. So what about the time and space complexities for this problem? Well, the space complexity is going to be O of n, where n is bound to the length of our stack. So we will say stack.length. And then the time complexity is also going to be O of n, where n is the number of nodes traversed, right? In the worst case possible, we have to traverse all of the nodes in the tree before we find a target sum, or we don't find a target sum. So the time complexity is going to be O of n for this problem. And that'll do it for LeetCode 112.